All right, so first of all, we're going to wrap up the 6.8 section, which was talking about minimums, maximums, increasing, decreasing, things like that. Okay, we did the first few problems and the last few problems. So what we have left are 7, 8, and 9 in this section. All right, so on number 7, it gives us this function. It tells me what this vertex is. Okay, it just spells it out for me. And then it's going to ask me several different questions. First of all, the first thing it's going to say is, does this function have a relative maximum or minimum? What is this vertex? It's the maximum, right? Since it's at the top. And then it's going to say the relative maximum occurs at x equals blank and has a value of blank. So remember, the value, when the word value comes up, it's always going to be that y coordinate. Okay. It's also helpful that it tells you the maximum occurs at x equals. So what's going to go there? Your x coordinate. 6.5. And what's the value of that maximum? 3.25. Good. The last thing it's going to ask you is, on what intervals is it increasing and what intervals is it decreasing? Okay, so we did a lot of this on Wednesday. If your values are going up, which is this side right here, that's your increase. Once it gets to the maximum, what do your values start doing over here? Decrease. They start to decrease. Okay, so what interval is it increasing? Where does it start increasing? Negative infinity until it gets to 6.5, right? Because when we do increase and decreasing, we use the x coordinates, and everybody has parentheses. So from negative infinity to 6.5, which is where it starts to do what? Decrease. So it decreases from 6.5 to positive infinity. That's number 7. All right, number 8. All right, number 8 looks like this, and it tells me what each of those points are. This one's at -7, -1, and this one's at -3, -9. So this one has a maximum and a minimum. So here's my maximum. What is the maximum? At x equals blank. So what's the maximum? -1, right? The maximum value is always the y. It occurs at x equals -7. And here's your minimum. What's your minimum value? -9, and it occurs at x equals -3. And then increasing and decreasing. This one actually has 2 intervals where you're increasing, correct? Your values are going up on this interval. So that's an increase. Then it decreases here between the 2 points. Then after it passes through this minimum, it starts to increase again. So the increasing intervals start all the way to the left, which is -infinity, until it gets to -7. And it starts increasing again at -3 to +infinity.
So you don't put a union, you just put a comma?
Right, and it's that part's is going to be multiple choice.
Okay.
Actually, they put the word "and" in between all the. And what interval is it decreasing? Where does it start decreasing? -7
to -3.
to -3. All right, last one in this section, number 9. All right, this one just wants to know where the maximum and minimum are, which means I just need to know the coordinates of these 2 points, right? Because the maximum value is going to be whatever that y coordinate is. So let's see, what's this one's x coordinate? You didn't go left or right at all, you just went up 1, so it would be at 0, 1. And what about this point? This will be your minimum. So right 2, down 3, so 2, -3. So let's see, the maximum is, what's the maximum value? 1, and it occurs at x equals 0. What's the minimum value?
-3.
-3, and it occurs at x equals 2.
We don't do increase or decrease. Right?
Not on that one. I mean, you can. It increases from what? -infinity to 0. It decreases from 0 to 2, and then it increases from 2 to infinity. All right, section 5.4 is going to be covering what's called the difference quotient. Difference quotient. Right, the difference quotient is used to find the average average rate of change of a function or a graph that's not a straight line, right? Because if you are a straight line, you come in the form of, y'all heard that y equals mx plus b, where m is your slope and the b is where it crosses the y-axis. It's the y-intercept. So it's easy to tell on a line what the average rate of change is, or the slope. But what if you're something like this and you want to find the average rate of change between 2 points like that? Okay, so this is just, and we don't really get too deep into it. That's in if you're going into calculus or something. But just to give you some background, like looking at number 1. Find the difference quotient for f of x equals 3x minus 7. So again, the difference quotient is finding the average rate of change or the slope. I can tell what this slope is. It's 3, right? Because this is a line. It can be in the form y equals, there's your m, which is your slope, x plus b. So my answer is going to end up being 3. Okay, but just to get some practice using the difference quotient and how it works, we're going to do a couple that are lines where you wouldn't necessarily need to do the difference quotient because you can tell by looking, but again, it gives us some good practice. So what's going to happen is in the numerator, the first thing you're going to do is go to your function. Everywhere you see an x, you're going to put an x plus h. Right? That's what this means. F of x plus h means go to your function, replace the x with x plus h. So that's going to look like 3x plus h minus 7. Now, the second part of the numerator says to subtract your exact function. So this right here, you're going to subtract in parentheses, right? That way you know you're subtracting the whole function and not just the 3x. So minus 3x minus 7. Now, the denominator is always going to be h, but the numerator is where you're going to have a lot of work in. So let's go ahead and simplify the numerator as much as we can, and then we'll just throw the h in the denominator after that. Okay, so let's see, to simplify, I need to remove parentheses. So I've got 3x plus 3h minus 7. Here I'm going to distribute this negative. So what's it? It's going to make this minus 3x and this plus 7. Okay. Now, when you distribute this negative to this parenthesis, it changes the signs and it makes it those terms, whatever you distributed the negative to, are going to cancel terms up front. Because what can you do with the plus 7 and a minus 7? Cancel. Minus 3x and plus 3x, cancel. So what are you left with?
3h over h.
Right. You got 3h, and remember your denominator is h. So those h's cancel. So the answer is 3, like we knew it was going to be. But again, just getting this practice is what we need from this right now. Number 2 is going to be very similar. F of x is negative 5x plus 6. So this one's linear again, right? Because x is just x. It's not squared or cubed or anything like that. So my answer is the slope, which is going to end up being negative 5. So first things first is to write the function and replace the x with x plus h. So I have negative 5. In place of x, I'll put x plus h plus 6. Then subtract your function in parentheses. So minus negative 5x plus 6. And then simplify. So I'm going to distribute to get rid of all the parentheses. I'll distribute the negative 5 here. So negative 5 times x is negative 5x Negative 5 times h is negative 5h. Bring down my plus 6. Distribute the negative, which is going to change those signs. And what is changing those signs going to do? Make those terms cancel terms up front. So I've got plus 5x minus 6. So the minus 6 cancels the plus 6. The plus 5x cancels the negative 5x. So all you have left is the negative 5h, and it's over h. So your h is canceled. So you're just left with negative 5. Now, on number 3, my function is f of x equals x squared plus 7. This is where it gets a little messy. What's your first step? To rewrite the function. Wherever you see x, put x plus h. So instead of x squared, I'm going to have x plus h squared plus 7 minus the actual function in parentheses. So now I've got to do x plus h squared. So what I highly recommend is doing x plus h squared once and then highlighting it or circle it or something so that you only have to do it once. And then every time you see x plus h squared, you just grab that. Okay? Because what does x plus h squared mean I'm doing? That's right. Well. So my first x times x is x squared. My outer x times h is xh. My inner h times x is another xh. And my last h times h is h squared. How many xh's do you have? 2. So you've got x squared plus 2xh plus h squared. So again, I would just make that noticeable in your notes so that you don't have to FOIL every single time you need to use x plus h squared. You just do it once and then use it all the time. So in place of this, x plus h squared is what we just did here. So x squared plus 2xh plus h squared plus 7. Distribute this to change those signs. So that's going to be minus x squared and minus 7. And then clean it up. Right? Everything you distributed to minus 2 is going to cancel something. The minus 7 cancels the plus 7, and the minus x squared cancels the plus x squared. So let's see, what are you left with this time? 2xh plus h squared over h. Now, what does the numerator terms have in common? What do they both have? H, which means you can pull that h out because it's the common factor. If you take the h out of each of these terms, what's left in the first term? 2x. Plus, if you just took an h out of this, you still have an h, right? Because you had h squared and took 1 away. What's your denominator? 1. So what happens here?
Cancel.
They cancel. So every single time, once you clean it up, all the terms that you have left are going to have an h in them. So you're going to pull out the h, put in parentheses what's left, and use that h that you pulled out to cancel the denominator's h. So all you're left with is 2x plus h. All right, that was 3. So number 4. F of x is 10x squared plus 2x plus 4. All right, first things first, replace your x's with x plus h's. So I've got 10 instead of x plus h squared plus 2. There's another x, so x plus h plus 4. So again, this is the function with the x's replaced with x plus h's. Then subtract the actual function. So I'm subtracting 10x squared plus 2x plus 4. Now, the only thing, you've got to take care of this exponent first. So x plus h squared. Remember, we've already done it, so no need to do it all over again. Where do you put in place of x plus h squared? This right here. Right? So what do I have? I've got 10 x squared plus 2xh plus h squared. Now, go ahead and you can fully remove those parentheses now by doing what? Distributing this 10. So 10 times x squared is 10x squared. 10 times 2 gives me 20xh. Plus 10 times h squared gives me plus 10h squared. So that took care of all of this. I did the FOIL and then distributed the 10. Here I need to distribute the 2. So I've got plus 2x plus 2h. That got rid of those parentheses. Bring down the plus 4. And distribute your negative. Again, that's going to help this clean up a lot, right? Because what happens with all those terms? They're going to cancel terms up front once you change their signs. So it'll be minus 10x squared minus 2x minus 4. Now do your canceling. So the minus 4 cancels that plus 4. The minus 2x cancels that positive 2x. The minus 10x squared cancels the plus 10x squared. Now, what's left? 20xh plus 10h squared plus 2h. So again, what do all the terms have in common that you can pull out? H. And then you'll use that h to cancel the denominator. So if I pull the h out here, I'm left with 20x. Plus, if I take an h out of here, I still have 10h. Plus, take that h out, which just leaves me with 2. So your denominator is h, so those cancel. So you're left with 20x plus 10h plus 2. Last one. F of x equals 3x to the third. Remember, we're just going to do this once and save it also, right? Because what does x to the third mean? Or I'm getting ahead of myself. So what am I going to do first? Put a x plus h right here. So x plus h to the third, or 3x plus h to the third, then minus the actual function, 3x to the third. So what do I have to do first? X plus h to the third. Now remember, actually I'm gonna bring it over here. Because what does x plus h to the third mean I need to do? Yeah. Now, I have a little bit of a shortcut because I've already done that, right? I've already foiled the first two together when I did x plus h squared. So when I foil here, I've got x squared plus 2xh plus h squared, right? That's from when I did it on the x squared problems. So now I have to multiply this times this last x plus h, which means you distribute everything in that first parenthesis to the second parenthesis. So the first thing I'm distributing is x squared. Right. So x squared times x gives me x to the third. X squared times h just gives me x squared h. Now I'll distribute this term to both of those. So let's see, I've got 2xh times x. So who's going to end up being squared in this situation? The x's are, right? Because I've got x times x. So I've got plus 2. X times x gives me x squared h. Now, when I distribute this to the h, who's going to end up being squared this time? The h. So you're going to have 2x h squared. And then the last is to distribute this h squared to both of those. So let's see, h squared times x is just h squared x. And h squared times h is h to the third. Now, let's clean it up a little bit by combining like terms. And remember, to be a like term, you have to have the same variables, and those variables have to have the same exponent. Are there any other x to the thirds? No. X squared h, x squared h. So these terms can go together. They're both x squared h's. So if this one's 1 and that one's 2, altogether you've got 3 of those. Plus 3x squared h. Now look at these. Those are actually like terms also, right? Even though the x and the h are flip-flopped, there's still an x with an h squared and x with an h squared, right? To be like terms, you just have to have the same variables, and those variables have to have the same exponent. They don't have to be in the same order. So how many of these do you have? 3 of those also. Plus 3, and you can write it either way, h squared x or xh squared, it doesn't matter. Then what? Plus h to the third. So you've done it once. Your number 5, when you're doing your homework, is going to have an x cubed in it. So you've already done that. So just make sure you highlight that so you don't have to do it again. Anytime you see x cubed or x plus h cubed, you'll be able to just grab that. So now back to the problem. What do I put here? Everything I got over there. So I'm going to just bring down the 3. X cubed plus 3x squared h plus 3 with the h squared x plus h to the third. Then just bring down the minus 3x to the third. Distribute your 3 here. Remove those parentheses. So let's see, 3 times x squared is 3, I keep saying squared. 3 times x cubed is 3x cubed. Plus 3 times 3 gives me 9x squared h. Plus 3 times 3 again is 9h squared x. Then 3 times h cubed is 3h cubed. Bring down the minus, 3x cubed, which will cancel the positive, 3x cubed. Okay, now for sake of board space, I'm just going to go ahead, instead of rewriting this and then pulling out the h, I'm just going to go ahead and pull out the h, right? They all have that h. So when you pull it out, you're going to be left in the first term, which is 9x squared. Plus 9, it had h squared. If I take 1 out, I still have h. X plus, take an h out, so I still have 3h squared. And the denominator is always h, and those h's canceled, so here's your answer. All right, let me take roll. Nicholas Anderson. Bear with me. Cedric Brown. Michaela Bryant. Jalen Collins. Isabella Crumpton.
Here.
Julia Germain. Jonathan Honorable. Debbie Mosby. Declan Oleski, I see you online. Hallie Pridmore. John Richardson. All right, and Kendricks, I got you. All right, y'all have a good weekend. I'll see y'all on Monday. I can take my turns off already.
That was the last part, the 27th.
Yeah. Yeah. So 7.5, 6.1 and 6.8 and 5.4. And I do know who you're talking about. I think that Will, is it Will Tora? I think he didn't come in there until, I think so. I don't think he comes in there until 12 though. And he doesn't come in there on Fridays. I think because it's calculus that I think he's in. You saw this one?
So do they have a grace period where like, or do you extend your, basically I have to pay, I guess like the tuition by March 7th, but I've been trying to process my FAFSA, but it's not processing because I guess I didn't do it right or whatever. And I'm trying to get my W-2 from my previous job, but I don't know if it'll be in time. And I don't want them to charge me again.
Right.
They had charged me and I still haven't got refunded for that process. You know?
I don't know just because I don't, financial aid and all that is so confusing to me. But you can go to the business office, you know where that is? I don't, because I'm honestly, I just don't know much about.
Like, probably if I just take my card off,
I don't know.
I would really like to avoid.
Yeah.
Like the one I did, I guess I did it for the 2023 year instead of the right year. But the lady in the office, I kept telling her, like, "Can you please bring her and look." Because I went in there in her office to do it. And I don't know why, but she just wouldn't look.
That's her job, isn't it?
She kind of refused to get up and like come in here and like look. And I guess I messed up. I'll figure it out.
Wouldn't think they would drop you. I don't think I've ever had somebody be dropped that late in the semester for. If they can see that it's pending, you know. And next semester, you'll get a class paid for being that note taker.
Oh, yeah. I remember. But I have a youth job interview pretty soon. I'm be dealing with like 17-year-olds. I guess they're really, really bad, but I kind of wanted to like be the person that I don't have an influence on them.
To change it, to help them and.
You know, different stuff, but I want to show them like, I don't know, kind of like stuff on them too, to see like, I feel like everybody's into something. You gotta just
Sure.
find it.
Yeah. You know, a lot of those kids, they just haven't been given a chance, you know.
And I want to just kind of important, like, this stuff,
Mm-hmm.
like, have you ever taught at like an elementary or a high school?
I did a little bit of middle school, 6th grade. It's hard. I mean,
Is it hard because the type of person you are? Or would
I
you
just-
say it's
I-
hard in general?
it's just because the type of person I am. You know, some people thrive at it and love it. It's hard work being a middle school teacher. You know, I mean, those kids, they're, you know, hormones are just starting to, you know, it's just a hard age. It's hard to be that age, and it's hard to have a classroom full of people that age.
You don't get a video assignment like on my lab.
Yeah,
on
you
my
can.
lab.
Yeah. Is there one that you need reopened?
Because I missed a lot of assignments, and this is mainly because of work, and I had to change my schedule so I could have more time to do schoolwork.
Mm-hmm. Where are you working?
Working at Subway on Gravel Ridge, and
Okay.
I work at like 4 to close most of the time.
Yeah.
And it's like I'm not trying to entirely blame it on just the job and everything, because I go right after I go out to school, and I work till 9, then I get home at like 11 and everything like that. So it's like I'm in a really bad mix of it. And it's like I'm trying to I talked to her about it. She's willing to change my schedule around where I have more time to do my assignments. So I wanted to know if I would be able to
Yeah. I
go
mean,
back and do at least the majority of them. I'll take like a lower grade or anything on them, but I at least want to get them done. It's better than 0.
sure. Yeah. Yeah. I'm trying to open it.
I know for a fact I missed the last exam. That's because I got the date wrong. Because I wrote it down in my phone calendar and put on the wrong date. And got it wrong. And I usually don't do that, but it's one of those times, and I'm not trying to fall behind because I'm.
No, you're here every day.
Yeah. But I do have the majority of what's going to be due this week done. And I was just wondering, since I'm about to be done with that, I got like one more to do, and I'm almost done with that one. I was gonna be able to go back and do a couple of them.
Okay, so I'm about to, it's taking, my computer's got some kind of virus or something like that, so it's taking forever to do anything.
I think it might be MATLAB. It takes a little bit for my computer to
Oh, really?
get on MATLAB, and mine's brand new.
Oh,
I didn't get my computer till like this semester. I got it for school specific.
all right, what's your last name?
Mosby.
Oh, that's right.
MOS.
Uh-huh. Yeah, you're done with most stuff for this week.
And I just wanted to comment on if
Yeah, so I'm gonna open up the review also, the review and the test, and then those couple of homework assignments that you need. Do you think you can get it done by Sunday, this Sunday, or? Here's the thing, I'll put it due Sunday, and then when you come to class on Monday, let's revisit it and see which ones you still haven't done, and I can reopen those, just to keep it a standard Sunday due date. So I'll put them due this Sunday, but again, we'll revisit it and on Monday and go from there.
Because I can work on it today and tomorrow, because I'm off for work today.
Okay.
And Saturday.
Okay,
So I'm trying to take that time to get a lot of my other stuff done, so I
Right.
don't have to worry about it or fall behind. too
Yeah.
much.
okay, so I'll put them due this Sunday, the 27th.
Yeah.
Yeah.
What was I about to say?
I do that all the time.
I'm trying to think of it. Wait, today 25th or 26th?
25th.
25th? Okay. Yeah, okay. You said the review, you open the review?
I
too,
opened the
so I can look at
review and the test,
that? Okay,
and then there's a couple of homeworks too
okay.
that I'm opening.
All right, thank you.
You're welcome.
You said that by Sunday, right?
Yeah, Sunday. And then on Monday, we'll revisit and see
Okay.
where you are.
All right, thank you.
You're welcome.
You have a good weekend.
Thank you. You too.
Thanks.
Mhm.
Did you have to break up the fight?
No,
Did you work there for a long time?
no, I didn't work there very long at all. What wore me out more than the students were some parents that, just didn't believe that their kid would act up in class and
Yeah. Some people are, it's hard to believe your student act like that when their mom is probably really quiet. My teachers always told me, in certain ways, we are like your parents because you spend more time with us than you do at home.
yeah, I mean, you really do. I mean, where'd you go to school?
I went to, like, you talking about high school?
Yeah.
I went to Mills.
Oh, yeah.
For a long time, I was in like the Mills extracurricular
Mhm.
classes like tag and but the amount of work, I don't know if you've ever heard of Miss Moss, have you?
Mm-mm.
She should be like a college professor. She would assign so much work. Have you ever heard of Miss Rollins? She was a AP art history teacher.
Oh,
She
no.
had been there for like years, I think like 60 years or something like that. She was there for a long time. I think she's retired now. The amount of work that they would assign was insane. So I switched over to regular classes to kind of see how it would be.
Uh-huh.
And regular classes were so easy. It's like elementary easy. But I didn't like the way that they I didn't like how easy they were. They were like
You needed something in between.
You yeah, something in between. It's like I do want to learn, but I feel like I definitely am more mature now, and I understand like how important it is for
Right.
kids to actually learn. But like, I feel like the way that they was teaching, it wasn't helping like students grow. So some of their mentalities was still like elementary, like or
Right.
simple-minded about certain things.
Right.
Did you go to high school here?
I did. I went to high school in Little Rock at an all girls high school.
What? Was it religious?
Yeah, it was a Catholic school.
Oh, how was that? Was it not just like private?
Yeah. Yeah, I mean,
Would you say that's why you're so good at math?
I did have good math there. Math and English were really hard there.
Most private businesses are really always better take care about it more. Did you hate it when you was in school?
No,
You did?
no, I didn't mind it. No, you just, you didn't care about getting ready for school or anything. You just woke up and went. It's all girls, So nobody,
It had to be some of those girls had to be complaining though, right?
oh, I'm sure, yeah.
You know, as a teenager, like kind of like rebellious,
Yeah. And I had a lot of friends that went to, other schools and stuff.
Did y'all have like a basketball team?
Hmm. Yeah, they had, basketball. Softball, volleyball, swimming.
I went to my elementary school it was at a church, but it was not a religious place. It was called Dreamland. Have you ever heard of
I
that?
haven't heard of that. Dreamland Academy or something like that.
It was pretty bad actually.
Where was it? Where is it? I know I've heard of it.
It was in Southwest on base. I don't want to say baseline or Dire Springs. I'm not sure. But it's kind of like really close by university. It's
Uh-huh.
Greater Second Baptist. Have you ever
Uh-huh.
heard of that church?
Uh-huh.
That's right there. It was really, really big. I think it had like a lot of potential, especially for the location and different stuff. I don't know. I think they're like out of. I think they reclassified. I mean, changed the name or something. Oh, and I did go to a private school that I had to wear a uniform. Well, I guess that doesn't mean like private, but it's like the closest.